and welcome to our next video in the series of reaction stoichiometry calculations. In this video we're given grams of one substance and we need to calculate grams of a different substance. This video looks at method C. That is just an arbitrary name we give to this method to say that it's a little different than method A or method B. And you're welcome to view those videos as well and select the method that makes most sense to you. Our stronger students tend to learn or at least become familiar with all three methods so that they can choose which method to use for any given problem. Sometimes one method is a little easier than others. Alright, so we've already in the other videos looked at how to write the balanced chemical reaction for propane burning in air. Propane is C3H8 plus O2 gives CO2 plus H2O. We're going to be very good at balancing this equation by the end of these three videos. Alright, so we've written out the balanced chemical equation now, and the next thing we will do is write what we're given, 92.6 grams of propane and X grams of O2. Alright, for this we're going to use ratios. For this method we'll use ratios again, but this time we'll ratio according to mass. Okay, so we're going to do ratios with grams. Now previously in method B we did ratios with moles using the balanced chemical equation. Now we'll ratio with grams, and in order to do that we need the molecular weight. So I need to know how many grams for C3H8 if we have, okay, so this is going to be the coefficient in the balanced chemical equation times the molecular weight of C3H8. Okay? Alright, so the coefficient is 1. Now let me correct that. It is 1 mole C3H8, and the molecular weight is 44.11 grams C3H8. Now I'm writing this all out, per mole C3H8. I'm writing all this out. However, most people, once they become familiar with this method, just do it. Like, they don't write all this, right? They just write 44.11. Okay. So then I also need 44.11. Okay, so that's grams. Then I need the O2. Okay, and I'll do the same thing. So I do 5 moles of O2 times 32.00 grams of O2 for 1 mole of O2. Again, if I were doing this like on a timed test, I would just do 32 times 5, but I want you to see that the math works out. So I'm writing it out, and that gets me 160 grams of O2. Alright, now I write my ratio. So for every 160 grams of O2, I need 44.11 grams of C3H8. I'm going to stop here, pause for just a second. Notice the balanced chemical equation we've established is 1 mole to 5 moles of O2. Well, 1 mole is 44.11 grams, and 5 moles of O2 is 160 grams. So that's what we're doing. So we're still telling the same thing, it just has grams built in. Then we go to the other side and we say, oh, well, I want to know how many grams of O2. If this time we don't have 44.11, we have 92.6 grams of C3H8. That's what was given. So now I can cross multiply and solve, and I will get 336 grams of O2 are needed. Okay, and this is method C. And if you look at the math across each of the methods, A, B, and C, the math is always the same numbers multiplied, the same numbers divided. It's just a little bit different thinking that goes into it for setting it up. So whichever works for you, I recommend you use that one. Thank you. See you next video.